Assalamualaikum and hi everyone. In today's video, we will explain about one of the application of differentiation, which is related rate. Let's meet our splendid group members first. Our group consists of 3 members, which are Ain Nazirah binti Nur Hazlan, Azurin Najwa binti Azrai, and Nurfati Najwa binti Rabain. We are from class P2PH 1102C1. Time is gold, so let's get started with the introduction about this topic.
What is differentiation? Differentiation is a process of finding derivative or rate of change of a function. Why do we use it? It is because differentiation is actually a process of finding derivative or rate of change of a function. There are 3 techniques that can be used to solve the differentiation problem. The first technique is the derivative of sum and difference. The second one, derivative of product function, that also can be called as the product rule. And lastly, the derivative of rational function, which is the quotient rule. Rate of function also can be defined as dy over dx or fx or y. We had learned in our class about 6 applications of differentiation, which are related rates that have the same meaning as rates of change, analysis of function 1 that include increase, decrease, and concavity. Thirdly, we have analysis of function 2 that have relative extrema, and also first and second derivative tests. After that, we have graph of polynomial and rational functions, then maximum and minimum problems, and lastly, we have learned Rolle's theorem and mean value theorem for differentiation. Let's dive in deeper into our main topic today, which is related rate. Related rate is a problem that involves 2 or more variables that change at the same time, possibly at a different rate. In a simpler way, we can conclude that related rate is a problem that involves at least 2 changing quantities. The rate of change usually with respect to time, which is dy over dt. In a problem that involves related rate, the idea is to compute the rate of change of another quantity. If we want to solve the problems of related rate, there are 4 steps that we need to follow to help us find the answer. The first one, draw a diagram if possible and label the quantities. Then, find an equation that relates the quantity of rates of change that to be found with the one that is already known. Thirdly, use the chain rule or implicit to differentiate both sides of the equation with respect to time. And lastly, solve for the derivative that will give the unknown rates of change.
Next is the problem solution, which is the question that we will solve after this is the question that are related to application of differentiation, which is the rate of change. So the question is, considering a perfectly spherical balloon being filled with air, the balloon expands at a rate of 3 cm³ per second. When the balloon's radius is 4 centimeter, how fast is the radius increasing? So before we start doing our questions, we should understand the questions perfectly and identify any information that we can use to solve these questions. So from this question also we can find the objective is to find the rate of radius change when the radius of the balloon is in 4 centimeter. Basically, we want to find the rate of radius change, which is the dr over dt. And also we need to replace the radius with 4 centimeter. And from the equation also we can identify some information which is the dv over dt, which is 3 centimeter cube, per second. So before we start doing our calculation, we should draw a related diagram from the questions and also take up some information. It's not some, all the information that we got from the questions. So here I draw the perfectly spherical balloons with radius of 4 centimeter. And also from the question, we know that the dV over dt is 3 cm cubed per second. And what we want to find is the dr over dt. So the next step after we draw the diagram, we can start doing our solutions or calculation. So for this question, we can use chain rule method or implicit rule method. But I choose chain rule methods. So from the question, we need to find dr over dt. So I equal with dv over dt, which is the information that we got from the questions, which is 3 cm cubed per second. And then I times with dr over dv. So dr over dv is the first thing that we need to find before we try to find dr over dt, which is our objective for these questions. So how to find dr over dv? So to find dr over dv, we can use volume of sphere. Why we use volume of sphere? Why sphere? Because from the question, the balloon shapes is in sphere. So the volume of sphere is V equal to 4 over 3 pi r cube. Yes, and after we got the volume of sphere, as we know, if we differentiate V with respect to r, we will get dV over dr. So from dV over dr, we can also find the r over dV that we need to for our objective. So when we differentiate volume of sphere, which is the 3 from the r we brought to the front, and times with 4 over 3 with pi r square. Because we're doing a differentiation, so the power of r will decrease by 1, so it becomes r square. So when we calculate it in the calculator, it will become 4 pi r square. So this is the dv over dr. So when we need dr over dv, we just need to change the dr over dv position. So dv will become the numerator and dv will become the denominator and dr will become the numerator. So when we change it, it will become 1 over 4 pi r square. So we already found the dr over dv, and we also already has dv over dt from the equation, which is 3 cm cubed per second. So we can try to solve our objective, which is dr over dt. So first, dr over dt is equal to dv over dt, which is from the questions, which is 3, and then we times with dr over dt that we just found, which is 1 over 4 pi r square. And don't forget to uh, change the r with 4 centimeter, which is what the question needs. So when we put all this number into a calculator, we will got 0.015 centimeter per second. So the objective for the questions is achieved. So don't forget, and also don't forget the unit. By this calculation, we can conclude differentiation method is used to compute the rate of change. In addition, understanding of question is a vital for us to answer the question very well. Instead of that, we can apply this method in our daily lives if we understand what is related rates. For acknowledgement, we are very grateful because we managed to complete this video assignment within the time that given by our lecturer, which is Harry. This assignment is impossible to be done without the cooperation and effort from our group members, which is Ain, Azurin, and me, Najwa. We also to thank to our lecturer Sir Harry for guidance and willingness to assist us in what we are lacking when completing this assignment, and surely thank you for teaching us for this course. Last but not least, we also want to express our gratitude to our family members who keep on encouraging us all this time.